All right, we have one more performer. I'm so excited. His name is Brad Holschuh. He is from the Wearable Technologies Designer Department at the University of Minnesota. He's assistant professor and co-director of wearable technology. He's also a graduate of MIT and an engineer by training. He previously worked with NASA to develop advanced spacesuit technologies. What? Worked with NASA. I would be impressed if he just designed the Tang packaging, right? That's amazing. How did you get it to the straw to fit? But no, spacesuit technologies, this is so cool. And he works here at the U. Go find him. All right, well, I'm so excited to bring him to the stage. Please welcome Brad Holschuh.
All right, my mic live? All right, we're good. Well, thank you for that introduction. And as we heard, I am a brand new addition to the College of Design here at the U. I'm not a brand new addition to the state of Minnesota. I grew up actually up I-94 a few hours in Moorhead, Minnesota. Go Spuds, if there's any Spuds here. I heard one woo, that's good. Born and raised in Moorhead, but as we heard, spent the last 12 years of my life at MIT, from a starry-eyed freshman to a bitter, grumpy postdoc, through the entire lifespan of the academic career as a student, at least, in the Aero-Astro department, and was hired by the College of Design and started here in January. So when I was going through my job search last year, I knew that I always wanted to come back to Minnesota. I was from here, I knew this is where I wanted to be, so I looked at the job openings at the U and spammed it. I looked at everything that could possibly fit. I applied to the aerospace department, I applied to the mechanical engineering department, I applied to the biomedical engineering department, and I applied to the College of Design. And some of my colleagues at MIT looked at me and they said, "You're applying to the College of Design, and specifically, you're applying to be an apparel professor?" And I said, yes, and I knew what was going in the back of their mind was this. They're thinking, this is going to be his new life, and some of them actually started calling me Mugatu from Zoolander. I became Mugatu the engineer. So I came from my job talk, and I started presenting about some of my work with spacesuits, and I could see it in the faces of the people who I was talking to, that this is what they were thinking. They're like, we have an aerospace engineer here. This guy's actually even from MIT, so it's a perfect fit. This is what he's going to do. This is what we're hiring as an apparel designer. Are you kidding me? But luckily, I was able to convince them to hire me, and I did it because in the Venn diagram between aerospace engineering and apparel, there exists spacesuits. And that might be the only thing that actually counts as an overlap between aerospace and apparel, but damn it, I made sure that they believed me that that was a good reason to hire me. So what I want to talk about now is we're going to do a little bit of a deep dive into what it means to design spacesuits and why it's so important to have both a perspective of an engineer and also the perspective of a designer, and to think about why in all of our lives it's important to bring communities together that may or may not have stereotyped beliefs about the other. So this is a picture of Buzz Aldrin walking on the moon, 1969, wearing the spacesuit of the time, but frankly, it's the spacesuit of today as well. Very little has changed in the evolution of spacesuit design. The first and foremost reason for wearing a spacesuit is to stay alive. You're in the vacuum of space, you need something to protect you. And these suits do it, and they do it well. The secondary concern for spacesuits is to allow the astronauts to do their job, and this is where those suits failed and our suits today fail. So this is a video from Apollo 17, 1972. He drops his equipment, and look what happens. I wouldn't really call that a highly mobile suit. We spent millions and millions and millions of dollars to send people to the moon, and this is what they did when they got there. If you go to YouTube and you type in astronauts falling down, you'll see several videos like this. And this is what our suits to this day would do. We haven't been back to the moon since 1972, so there's no new videos of it, but the exact same thing would happen. And the reason why this happens is because the suits are balloons. They're a balloon. They're a balloon that's shaped like your body, but they're a balloon nonetheless. It's done for good reasons. You need something to breathe, so obviously you have to have a gas around you to breathe, but you also need pressure. You need pressure against your skin that we typically get from the atmosphere, but you need both of those things to stay alive if you're in a vacuum. And so when they designed the suits in the 60s all the way through today, they decided to kill both birds with one stone and put you in this balloon. But the problem with balloons is that they're stiff. And if you've ever played with a balloon, a party balloon, tried to bend it, it resists you. And that's what you saw here, and that's why the mobility is so terrible. There's an alternate way to design spacesuits, and it's to make them skin tight. This is a picture from 1971. So this concept predates the suit that we sent to the moon. And there are really, really good reasons to make it skin tight. You still have to have your helmet filled with gas. There's no way around that. You need something to breathe. But you can get the pressure against your skin from a material instead of from a gas. And if you do it right, you're in an incredibly tight leotard, but you're not in a balloon. And so you won't have these mobility problems. And there's proof of it. This suit was tested in the 70s. This is a subject wearing this suit. It's called the Space Activity Suit. And he can walk on a treadmill. He can crawl on a treadmill. He can climb up ladders. All of the mobility characteristics were proven. The problem, and the reason why we've never seen a suit like this in space, is because this particular suit required 3 assistants and 45 minutes to put on. And to give you an idea of why that's true, this suit needs to provide 1/3 of an atmosphere of pressure, which is a really hard thing to appreciate, but it's 10 times tighter than a medical-grade compression stocking. So this was 7 layers thick, and every layer got progressively tighter, but it was impossible to put on without help. And for that reason, it wasn't adopted in the 70s, and it hasn't been adopted today. And that is a travesty. So what I studied with NASA is developing the technologies to make this suit real. And how we did it, at least at the component level, is to look at materials that can change their shape. So we started developing shape-changing materials that can pull closed on command. And suddenly, if you have this type of technology, you can make a suit that shrink wraps you. So it's extremely easy to put on, but it tightens as soon as you flip a switch. And it tightens to the point that it can keep you alive in space. And these materials are in the realm of engineering, but they're also in the realm of design. And so Popular Science actually ran an article in 2012 of what they think the spacesuit of the future should look like. And you'll notice that parts of it are skin tight. And the only way to make this suit real and to solve these problems that have existed for 40 years is to bring together innovative designs with engineering solutions. And instead of having engineers looking at apparel designers and thinking Mugatu from Zoolander, and instead of having designers look at engineers like neckbeards from the 80s that have circuit boards strapped to their chest, you need to have these communities together. And if nothing else, my goal here at the U is to be the person that can communicate to both of these groups so that the next time we send people to the moon, or we send people to Mars, hopefully, they'll be wearing a suit that looks like this, and you won't be able to find videos of them falling down when we send them to Mars. So I think this is a good example of a generalizable theme that it's important to bring communities together and to not be afraid of the stereotype of that community and to actually try to understand what they bring to the table, because innovative designs and innovative solutions require multidisciplinary approaches. Thank you.